Hey guys, welcome back to my channel Informatics. In this episode, we'll be learning about the two Galilean moons of Jupiter's, that is Io and Europa. Now you might be familiar with these Galilean moons because I've told you about them many times. They are one of the types of moons in the Jovian system. Jovian system means the moon system of Jupiter's. And there are the four large moons of Jupiter's. They're known as the Galilean moons because they were discovered by the Italian astronomer Galileo Galilei in 1610. Those moons, they are Ganymede, Europa, Io, and Callisto. Now, Ganymede is the largest of these moons. It is the largest moon in the solar system. It is even larger than the planet Mercury. So it was larger than the planet Mercury, and scientists were about to consider it as a planet because of its size. But however, they did not because, as you know, I told you in one of my episodes, planet, they orbit around a star. For example, Earth, they orbit around the sun. However, this Ganymede, it orbited around Jupiter rather than the Sun, so it should be considered as a moon only, a natural satellite, because it orbited the planet Jupiter. And then comes Europa. Europa is one of the main targets for search of life beyond the Earth in the solar system. And why? Well, you'll be learning about that in this episode about Europa. And we have Io. Io is a world. It is a celestial body with lots of volcanoes. It is a volcanically active celestial body in the solar system. Then comes Callisto. Callisto is a moon with lots of craters. So in this episode, we'll be learning about Io and Europa in more details. So let's jump into the topic. The first moon we're going to take a look at is Io. Io is a moon with lots of volcanoes. It is the third largest moon of Jupiter's. It is the innermost Galilean moon of Jupiter's. And this Io, it has very powerful tidal forces. It stretches this moon. How? Well, because of the gravitational force pulling. The Jupiter's gravitational force, it pulls the planet from this side. Simultaneously, it is getting pulled by the gravitational force of the other moons on the other side. Now, mainly this Ganymede and Europa. So powerful tidal forces, it stretches these moons in various directions. It flexes its surface by as much as 100 meters. And in comparison, the most dramatic tidal range of the sea of Earth is just 80 meters, but here it is 100 meters. So this tidal force, this tidal activity, it heats up the Io's interior, and this interior, it's almost sulfurous rock. And if we compare this sulfurous rock with silicate rocks of Earth, sulfurous rock has low melting point. And as a result, Io's volcanoes, it becomes active, or Io becomes the volcanically active world, volcanically active celestial body in the solar system. And these volcanoes, they explode sulfur-rich magma onto the surface. And they also launch geyser-like plumes into the clouds. And these plumes, they're rich in sulfurous chemicals. Now, Io owes its colorful pizza-like appearance, right? Now, if we look at the image of Io, we can see that Io, it's like a colorful celestial body. Why does it appear like that? Well, it is because of the unique properties of sulfur on Io's surface. We find sulfur again. Right, now if we go to yellowish green areas, we can find that those are the areas with pure sulfur. Pure sulfur is located where yellowish green areas are there. Now if we go to the reddish areas, we can find those are the areas in which sulfur has been exploded from the volcanoes nearby, besides those areas. And if we go to the darker brownish areas, we can find those are the sulfur affected by the radiation by this volcanoes explosion or launching like geyser plumes. All right, now we'll be taking a look at Europa. Europa is the smallest moon in the Galilean moons of Jupiter's. Its icy crust gives it the smoothest surface of any other larger worlds or larger celestial body in the solar system. Any significant features, for example, is when a crater is formed in any other celestial body, it just, bends down a bit. In the rocky planet, it bends down. But here, when it bends down, it gradually slumps back again to the average surface level, when a crater is formed. So that's a significant feature of this Europa's crust. Now Europa, like Io, it has a powerful tidal force. If we take a look at the image of Europa, we can find there are many lines crisscrossing over the surface. Well, these lines, they're known as lineae, and these lines, they are the lines that has been separating because of these tidal forces. How does this tidal forces happen? Well, it's the same feature as Io. You know, the gravitational pull, it is getting pulled from Jupiter's gravitational pull and Io's from one side, and Ganymede's gravitational pull, planet-sized Ganymede's gravitational pull on the other side. Although this tidal force heats up the interior, it does not cause any volcanic eruptions. It melts down a vast ocean beneath the crust of Europa, and this vast ocean is one of the few places in the solar system which might be hospitable to life. So that's why they say that Europa is one of the main targets for search of life beyond the Earth in the solar system. Alright, so that's about the moon Europa. So in the next episode, we'll be learning about the other two Galilean moons, that is Ganymede and Callisto. Alright, so hope you guys enjoyed this topic. Thanks for watching. Bye-bye.